Now that you understand Bohr-Rutherford diagrams, I want to come back to the periodic table, and I want to talk about some of the families within the periodic table. So just a reminder that vertical groups in the periodic table are considered to be chemical groups. They tend to have properties with similar trends. So for example, lithium, sodium, and potassium, if you take a look and find them on the periodic table, they're all within the same group. They're within the first column. So they're considered to be a chemical family, and they have very, very, very similar properties. If you actually take a look after this note, there is a video of lithium, potassium, and sodium all reacting with water. They have a very characteristic reaction, and you're going to see that they're very similar reactions, but they just increase in strength. So this is a chemical family. Let's take a look at our first family, and our first family is called family number 1. It has a very specific name. This family is our alkali metals. So alkali metals are soft and they are very highly reactive. So that's our lithium, sodium, potassium that I was just talking about. They're actually so reactive when you mix them with just water, they'll actually ignite and catch on fire. So those are those videos that show you the alkali metals igniting and catching on fire. The reason that alkali metals are so reactive is, we can explain it now with our Bohr-Rutherford diagram. Now that we know how to draw a Bohr-Rutherford diagram, anything in the first column actually only has one valence electron. So since it only has one valence electron, it's really easy to lose that electron. So they react very, very, very violently. All right, let's take a look at our next chemical family, and our next chemical family is called the alkaline earth metals. So I've got a couple examples here: magnesium, beryllium, calcium. They're light and they're reactive. Now notice it doesn't say the word very reactive. Alkali metals are much more reactive than alkaline earth metals. This is in the second column, so we have 2 valence electrons. 2 valence electrons are harder to lose than 1 valence electron. This extra valence electron makes them less reactive than alkali metals. So they're reactive, they're just not as reactive as alkali metals. Our next chemical family that we're going to talk about, this should actually say group 17, so I'll change that. Group 17 is our halogens. So they are said to be very reactive nonmetals. So halogens are considered to be very reactive. The reason that they're very reactive is because they're in group 17. That means that they have 7 valence electrons. Remember that a shell is considered to be full at 8. 7 is almost 8. So it's very easy for them to gain an electron. So they are very, very, very reactive. It's easy for them to gain 1 electron, so they're very reactive. Examples of examples of halogens include fluorine, chlorine, bromine, and iodine. So if you actually take a look, you can see that they all look very different. Alkali metals look very similar. Halogens look very different. Fluorine and iodine look very different. They're different states, different colors. Our last family that we talk about are our noble gases. Our noble gases are actually group 18 in the periodic table. We also call them inert gases. The reason that they're called inert is because if you look at their valence electrons, all inert or noble gases actually have 8 valence electrons. That's of course with the exception to helium, which only has 2 valence electrons. Either way, 8 valence electrons, 2 valence electrons, both of these shells are considered to be full. Since they're full, they're not going to gain or lose any valence electrons. That means they're actually not chemically reactive at all. So we tell you in grade 9 that helium, neon, argon, krypton, they're never going to form a compound. They're never going to want to gain or lose electrons. That's not necessarily true. In grade 12, again, we're going to take a look at the times that these noble gases do form compounds. But for right now, we consider them to be highly unreactive, highly inert, and they are the least reactive of any of the known elements. So those are our chemical families. Make sure that you know those 4 names and take a look at those videos to see lithium, sodium, and potassium reacting in water.